Hello everyone, welcome to yet another session on learning about Ethereum. In this session, we'll be covering the introduction to regular audits. So what exactly are regular audits, you must be wondering. Regular audits are vital for ensuring the security and integrity of the smart contracts. Despite their advantages, smart contracts can have vulnerabilities that, if left unchecked, can cause financial losses, harm reputations, and legal issues. Audits help identify and mitigate these vulnerabilities by thoroughly examining the contract's code, logic, security practices, and ensuring proper implementation and robustness. We conduct regular audits for three reasons: vulnerability mitigation, security standards compliance, user trust, and confidence. Regular audits help identify and address potential vulnerabilities in smart contracts, preventing financial losses, reputational damage, and legal consequences. Security standards compliance. Audits ensure smart contracts follow industry best practices and security standards, building trust and reducing legal risk. User trust and confidence. Independent audits provide third party verification, enhancing user trust, encouraging interaction with the contracts, which contributes to overall success and adoption of the system. We have three types of audits: manual code review, automated analysis, and formal verification. In manual code review, experienced auditors examine the code line by line, uncovering complex vulnerabilities and evaluating the overall design and logic. In automated analysis, tools use algorithms to scan for unknown vulnerabilities, quickly identifying common security issues. In formal verification, mathematical methods prove the correctness and security of the contract, ensuring it behaves as intended and is resistant to vulnerabilities. For planning an audit, we define three major things, that is, define scope and objective, identify critical components, and assemble the audit team. The first step involves clearly defining what aspects of the smart contract will be examined and what vulnerabilities are targeted. Clearly outlining the scope ensures that the audit is focused and effective. To identify critical components, we focus on the contract's key functions and areas that require more attention. This approach ensures that the audit focuses on the most important parts of the contract. Assembling the audit team. This step includes auditors, security researchers, and legal experts for a comprehensive examination. Each member brings unique skills and perspectives, allowing for a more thorough examination of the contract. Manual code review. There are three major things: benefits of manual review, common vulnerabilities identified, and techniques for effective manual review. Manual code review is a crucial step in smart contract security. It allows experienced auditors to scrutinize code line by line. This deep dive provides a level of insight not always possible with automated tools. It can identify complex vulnerabilities like logical flaws that automated tools may miss. Common vulnerabilities identified. This includes common issues like re-entry attack, integer overflows, and unchecked external calls. It can also identify less common issues related to contract design and business logic flows. Techniques for effective manual review. Effective manual review involves employing various techniques. This includes using specialized tools like code analysis platforms and employing code inspection checklists. These tools and techniques help auditors to systematically evaluate code and uncover potential vulnerabilities. Manual code review. Manual code review requires a deep understanding of Solidity syntax, best practices, and common security issues. Experienced auditors can use various techniques such as code inspection, checklist, and specialized analysis tools to thoroughly examine the contract. The provided example code in the next slide defines a simple contract with two functions, set value and get value. These functions allow users to set and retrieve a value stored in the contract. While this example is basic, it highlights the need for careful code review. Even simple contracts can contain vulnerabilities such as re-entry attacks, integer overflows, and unchecked external calls. Here is the code, which uses a Pragma Solidity compiler version 0.8.0. We have a public variable value which is of type uint56, a function set value which takes an input value and equates the previous public variable to the value provided in the input, and the get value function to retrieve that particular value which is stored in the variable value. Moving on, we have automated analysis tools. We have two parts, that is, benefits of automated tools and popular tools which we can use. Automated tools play a crucial role in streamlining the auditing process by quickly scanning for known vulnerabilities, reducing time and effort for manual review. They are also essential for ensuring consistency and reducing the risk of human error. Popular automating tools include Mythex, Synther, Slither, and Oint are used for automated smart contract analysis. Mythex offers a comprehensive platform with a range of fresh features like static and dynamic analysis, vulnerability detection, and security reports. Slither focuses on the static analysis, provide detailed information about contract structure, dependencies, and potential security flaws. OENT provides a more specialized approach, focusing on the identifying vulnerabilities related to reentry attacks, integer overflows, and other common security issues. Using Mythics for automated analysis. Mythics is a powerful platform that offers a comprehensive suite of tools for automated smart contract analysis. It utilizes advanced and dynamic analysis techniques to identify potential vulnerabilities and security risks within your smart contract code. It provides a user-friendly interface and detailed reports that help you understand the detected issues and prioritize remediation efforts. To use Mythics for analysis, you can use the myth analyze command. This command takes the Solidity source code file as input and performs a thorough analysis. The results are presented in a detailed report that includes information about the detected vulnerabilities, their severity, and potential remediation strategies. Mythics can help you identify and address a wide range of common security issues, including reentry, integer overflow, and unchecked external calls, ensuring the security and integrity of your smart contract. Using Slither for static analysis. Slither analyzes the contract structures, dependencies, and potential vulnerabilities without executing the code, provides insights into the security risk early in development. The Slither command generates a detailed report. Moving on. Formal verification. This involves 3 steps: mathematical proof, tools and techniques, and benefits and challenges. Formal verification uses mathematical proofs to ensure the correctness of smart contracts. This rigorous method provides a high level of assurance, guaranteeing that the code behaves as intended and is resistant to vulnerabilities. It involves defining the contract's behavior, using formal logic, and then using automated tools to verify that the code meets these specifications. Tools and techniques. Several tools and techniques are used for formal verification of smart contracts. One popular tool is KEVM, which is a formal model of the EVM, that is the Ethereum Virtual Machine. This model allows for rigorous analysis of smart contract behavior and identification of potential issues. Another approach involves using proof assistants like COC, which enables the creation of formal proofs about smart contract properties. Benefits and challenges. Formal verification offers significant benefits, including enhanced security, reduced risk, and increased trust. However, it comes with challenges. The process can be complex and time-consuming, requiring specialized expertise. Furthermore, a formal verification tool may not be readily available for all programming languages or platforms, limiting their applicability. Example of formal verification. Formal verification ensures the code behaves as intended by using mathematical proof. The provided example demonstrates a simple formal verification process using the COQ theorem prover. This code provides the commutative property of addition: a plus b is equal to b plus a for natural numbers. This example illustrates how formal verification can be applied to very specific properties of code, providing a high-level assurance about the code's correctness and security. In this slide, we'll learn about continuous monitoring and audits. Importance of ongoing monitoring. Continuous monitoring is crucial for maintaining the security of smart contracts. It involves actively tracking contract behavior to detect vulnerabilities and suspicious activities. By continuously monitoring, you can quickly respond to these threats and prevent security breaches. Tools for continuous monitoring. OpenZeppelin Defender and Etherscan are valuable tools for continuous monitoring. OpenZeppelin Defender provides automated security features including cache optimization and transaction monitoring. Etherscan offers real-time contract code analysis, transaction tracking, and vulnerability detection. Combining monitoring and periodic audits, integrating continuous monitoring with regular audits creates a comprehensive security framework. Continuous monitoring provides real-time insights into contract activity, while periodic audits offer a deeper analysis, identifying potential vulnerabilities that may not be apparent during routine monitoring. Moving on, we have incident response and remediation. This involves 3 things, that is, prioritizing and fixing, documenting remediation steps, re-auditing for verification. Address vulnerabilities based on severity and impact, ensuring thorough remediation. Document remediation steps involve keeping detailed records of vulnerabilities, fixes, and reasoning for future reference. Re-auditing verification conducts re-audits to confirm the effectiveness of fixes and ensure the code is secure. This helps the confidence in the security of the smart contract and helps to identify any remaining vulnerabilities. Documenting the audit process. In record findings, we detail every vulnerability, its severity, and potential impact. Recording the findings clearly helps auditors and developers understand the security risk and prioritize remediation efforts. Maintaining audit trails involves keeping records of audit actions, tools, and methods, verification steps for transparency and reproducibility. This audit helps ensure transparency, accountability, and reproducibility, allowing for independent verification and scrutiny. Ensuring transparency. Clear and concise documentation enhances transparency and fosters trust among stakeholders. It provides a comprehensive overview of the audit process, demonstrating the auditor's professionalism, expertise, and diligence. This transparency helps stakeholders understand the security and posture of the smart contract and build confidence in their reliability. Reporting audit results. This involves three major steps, that is, structure of an audit report, highlighting critical issues, and providing actionable recommendations. Structure of an audit report involves an executive summary, methodology, list of vulnerabilities, and remediation recommendations. In highlighting critical issues, we prioritize and clearly highlight the most severe vulnerabilities, and which allows developers to focus on addressing the most serious vulnerabilities first, providing actionable recommendations. In this, we offer specific, realistic guidance on fixing vulnerabilities with clear explanations, ensuring that developers understand the rationale behind the suggested solutions. Example of an audit report. Introduction and scope. A thorough audit report outlines the purpose and scope of the audit. It details the smart contract analyzed, the methodologies employed, and the specific vulnerabilities targeted. Summary of findings. The report concisely summarizes the key vulnerabilities identified during the audit process. It includes a list of the vulnerabilities, their severity levels, and potential impacts on the smart contract security and functionality. Detailed analysis of and recommendation. Each vulnerability is thoroughly analyzed, providing a detailed description of the issue, the potential consequences, and specific remediation strategies. The report also offers actionable recommendations to mitigate the identified vulnerabilities and enhance the overall security of the smart contract. Best practices for conducting audit. These are regular scheduling, combined methods, and third-party expertise. Regular scheduling involves establishing consistent audit schedules to proactively identify vulnerabilities. Regular audit enable a timely response to evolving security threats and ensure the contract remains resilient. Combined methods. They use both manual and automated methods for comprehensive audits. This combination enhances the effectiveness of audits, maximizing the identification of security risks. Third-party expertise. Engaging third-party auditors provides an unbiased and independent perspective. Independent audits help mitigate potential biases and ensure that the assessment is conducted with objectivity. This practice fosters confidence in the audit results and strengthens the trust in the smart contract security. Moving on, we have case study on regular audits in action. The first one is Decentralized Exchange Project. A decentralized exchange, that is DEX project, was launched to facilitate secure and transparent token trading. This project implemented a complex smart contract system to handle order matching, token transfers, and liquidity provision. To mitigate security risk and ensure a robust and reliable platform, the project incorporated regular audits into its development process. Audit processes and tools. The DEX project employed a combination of manual and automated audits to comprehensively assess the security of its smart contract. The audit process involved code reviews, formal verification, and vulnerability scans using tools like Mythics and Slither. These tools help identify potential security flaws such as reentry attacks and integer overflow. Outcomes and improvements. Regular audits revealed several vulnerabilities in the early stages of the DEX projects in development. The project team promptly addressed these issues through code modifications and enhancements. These improvements strengthen the security of the smart contract system, mitigating the risk of attacks and ensuring the safety of user funds. In this slide, we learn about challenges in conducting audits. These involve complexity of smart contracts, evolving threats, and resource constraints. Complexity of smart contract requires specialized knowledge to effectively analyze and identify vulnerabilities. This complexity can make it challenging to perform thorough and comprehensive audits. Evolving threats. The security landscape is constantly evolving, with new vulnerabilities and attack methods emerging regularly. Keeping up with these changes requires ongoing research and development, enabling auditors to stay ahead of emerging threats and adapt their auditing techniques to address the latest vulnerabilities. Resource constraints. Auditing is resource intensive, needing skilled auditors and advanced tools. Resource constraints can limit the scope and depth of audits, potentially hindering the identification of critical vulnerabilities. Conclusion and next steps. In this video, we learned about regular audits, which are essential for smart contract security, help to identify and address vulnerabilities. We prioritize continuous learning, stay updated with the best tech practices, and explore new tools and techniques to enhance security. Embrace a proactive approach to security, adapting to changing threats and implementing the necessary measures to protect your smart contracts. Thank you and have a great day.